I'm just creating this video because let's say that you're having problem with limiting reactants. I'm gonna post this on Shubi and I'm gonna post it on YouTube so you have a reference and you can use this example to complete like word problems involving limiting reactants. In what are limited reactants? You can see over here in the definition, the limited reactants is the extent of the reaction and thereby determines the amount of product that will be formed. What does that mean? That if you don't have enough of one of the reactions, the reaction is going to take place until that limited reactant is totally consumed in that reaction. How are you going to find limited reactants? That's the objective of this video. Now, to understand that better, I was writing over here an equation. This is my balanced chemical equation, and as you can see, you have the coefficients in purple in there. According to this balanced chemical equation, see, you know that these two are the reactants, okay? According to this balanced chemical equation, for 2 mole of irons, you need 6 mole of hydrochloric acid, or you can simplify that and you can say that for 1 mole of iron, you need 3 moles of hydrochloric acid. But let's say that I have the same 6 mole of hydrochloric acid, and instead of having 2 mole of iron, I have only 1. Do I have enough iron to react with all the hydrochloric acid? That's the concept behind limited reactants. So let's say that I have the 6 mole of hydrochloric acid, but only 1 of iron, and I'm going to have enough iron to react with all the hydrochloric acid that I have. That's what we call in chemistry limited reactants. Now, in this part of the course, you're going to solve problems to find limited reactants. Why limited reactants? Because then you need to use that mole ratio to find the amount of products that are going to be produced. This is the problem that I was showing you in the visual presentation. Yeah, I'm creating this video because I want you to get rid of all your excuses. You don't know because you don't want to know. It's not that you don't know because Ms. Ramos is not teaching this. That's what I am creating this video. And this video is going to be posted on YouTube and you're going to have access. Even if you go to college, you don't know how to do this, you can refer to this video to find limited reactants. Okay, stoichiometry problems involving limited reactants. As you can see in this question, they are giving you a reaction between solid sodium and iron trioxide. Okay, now they are giving you the amount of grams of sodium. Okay, remember that we're talking about limited reactants, so always I'm gonna give you the amount of the reactants in grams. Why in grams? Because I don't have any instrument in the chemistry lab that measure moles. See, so in this case, I'm giving you 100 grams of sodium solid and 100 grams of iron trioxide. They're reacting, okay? And I want to know in that reaction what is the limited reactants. Now, when solving problems like this, what is your first step? You're gonna follow the same procedure. Your first step is just to list information that you have. And what is the information that you have in this problem? The mass of iron oxide was given, it was 100 grams. The mass of sodium was given, it was another 100 grams. And I was explaining to you during like 2 classes ago that every time that you see grams involved in a problem, in an stoichiometry problem, just put on your list the molar mass of the substance that are involved. So here, even though it was not a given, it was not explicitly there in the problem, I was listing over here the molar mass of iron trioxide and the molar mass of sodium. Sodium is an element. You're going to find the molar mass on the periodic table. Iron trioxide is a compound, and you already know how to find that molar mass. Okay? So molar mass of iron, molar mass of oxygen, iron multiplied by 2, the molar mass of oxygen multiplied by 3, and then you add that. If that's the amount of grams that you're going to have in 1 mole. If that is your first step. And if you can see that, you have that on the visual presentation that I was sharing together with this video. So, step number 2, you already have your list with all information. Information that was explicitly there in the problem, information that you're going to infer from the problem. Because if you have the formula or the substance that are involved, you're going to be able to find the molar mass. My second step is just to balance the equation. Always, I'm going to give you the equation because I want to make sure that you don't make any mistake when you're writing the equation. So the equation always going to be a given. But the equation that I'm going to give you is going to be a skeleton one. So you have to balance that. Okay, so be very careful. When you're balancing equation, make sure that you have the same amount in the reactants than in the products. Because remember that the mole ratios you're going to use to solve the problems, they are coming from the coefficient from the balanced chemical equation. So second step, you have to balance the chemical equation. You have completed your list. You were reading the problem 1 sentence at a time, and then you were gathering important information, you put it on your list. Since you see or you saw the word grams on the problem, you were putting on your list all the molar mass of the substance that were involved. Step 2, you were balancing your chemical equation, and remember that we're talking about limiting reactants problems. So I'm going to be working with the reactants. I want to know what is the one that is going to be limiting my reaction. Okay? So I'm going to write the mole ratios of the reactants, mole ratio. Who's going to give me the relationship? The coefficient from the balanced chemical equation. And you have, see, two choices in here. You can write the mole ratio, or you can write the reciprocal of that mole ratio that is relating your two reactants. And according to the balanced chemical equation, okay, for 6 mole of sodium, you need 1 mole of iron trioxide. That's the original one, in case that you want to start with sodium. But if you write the other one, the reciprocal of that one, is fine. Okay, and the final answer is going to be the same. Once you have the mole ratios between the reactant given by the balanced chemical equation, you need to find the real mole ratio, the ones that you have with the data or the information that you have in your problem. According to your problem, only 100 grams of each reactant were available. Okay, mi Ramo, now I need to find the real mole ratio between the reactants, but I don't have the reactants in moles. I have that in grams. And that's why in this step, you have to use the molar mass of the two substances that are involved. If you look down here, I was converting the amount of sodium given in grams into mole of sodium, okay? And I was converting the amount of iron trioxide that was given in grams into moles, meaning that in the real situation, you don't have, okay, 6 and 1 or 3 and 2. No, you have 4.35 moles of sodium reacting with 0.63 moles of iron trioxide. And that's what you have to put over here. Okay? Remember that you're going to start with the iron trioxide, or you're going to start with the sodium. Okay? I'm going to start with the sodium because it's the biggest number. So according to my problem, I have 4.35 moles of sodium that are reacting with 0.63 moles of iron trioxide. Now, this relationship is telling me or is giving me an information. No way, Jose. And that's why I'm gonna divide the numerator and the denominator by the smallest number. Okay, so I can see that better. And if you look over here in my presentation, I was putting that there. So according to what I have in my mole of iron trioxide. Okay. According to what I have in the real situation, I have, see, only 1 mole of iron trioxide, and I have 6.90 moles of sodium. Okay, this is the new mole ratio given by, the situation that I have in my problem. Situation. Okay, so I have a theoretical. Let's gonna call that a theoretical mole ratios given by the balanced chemical equation, and I have a real one given by the real amounts that I have in that situation. Now in this step, I'm gonna compare. I'm gonna compare because I need to decide which one of the two reactants is limiting my reaction. Okay, this relationship that you have over here, this mole ratio that you have over here is given by the balanced chemical equation, which is telling you that for 1 mole of iron 3 oxide, you need 6 mole of sodium. Okay, this relationship that you have over here, or that mole ratio, is the real one that you have, which is telling you that for 1 mole of iron trioxide that you have that amount of sodium. So you have more sodium than needed if you compare that to the balanced chemical equation. And the decision is simple. You have a lot of sodium. So the one that is limiting, because 6.90 is bigger than 6. Okay, so the reactant that is limiting your reaction, the reactant is the iron trioxide. Okay, that's the reactant that is limiting your reaction. If you have only 2 reactants and the limiting one is the iron trioxide, what is the one that is in excess? That's a question for you to answer. I don't think that I have to go over this step, because if you have only 2 reactants and one of the reactants is the one that is restricting or limiting your reaction, the other one is the one that is in excess. Okay, in this case it's gonna be the sodium. If you arrive to that conclusion after analyzing the mole ratios given by the balanced chemical equation are the mole ratios that you have with your problem. Now, this problem is asking for the amount of iron solid that was produced. And you know that for that purpose, you have to use, okay, a mole ratio from the balanced chemical equation. Now, since we're talking about limiting reactants, are you gonna use any mole ratio? No. The answer is no. You're gonna be using the mole ratio that is relating the limiting reactant with that specific product. So the next step. So you already have the limiting reactants, you already have the reactant that is in excess, and now you need to find the amount of iron, but the mole ratio that you have to use is the mole ratio that is related, the limiting reactants with the product that you're looking for. Over here, I'm going to start, same procedure. I'm going to start with the mole ratio that is given by the equation. Okay, mole ratio that is given by the equation. I'm going to put the equal sign because remember that you're writing a proportion, and I'm going to keep the consistency. Okay, this is the amount in moles that I have of iron trioxide, and I know that because I was using the molar mass to convert the 100 grams in moles. If that's the amount that I have, with that amount, how many mole of iron are going to be produced? That's what I'm going to calculate. When you solve this proportion and you multiply 2 by 0.63, you divide by 9. This is the amount of iron that is obtained in moles. In moles. Okay? In moles. But the problem is not asking for the amount of iron in moles. The problem is looking for the amount of iron in grams. So you need to convert the grams into moles. After solving the proportion, you got the amount of iron that was obtained in moles. But you don't want that in moles. You want that in grams. That is why in this part of the problem, you have to multiply by this conversion factor. Conversion factor that is relating, the amount of grams that you have in 1 mole, and is known in chemistry as the molar mass. You learned that like a month and a half ago, but I'm repeating that because I know that you have some problem with the short memory. In case that you don't remember that, molar mass is the amount of grams that you have in 1 mole. So you multiply 1.26 by 55.847, divide that by 1, and that's how you get that number. You remember that we were looking for this amount of iron using the mole ratio that was involving the limiting reactant. Now, the last step or the last question that you have in this problem is just to find the amount of the reactant that was in excess that didn't react. So the amount that stayed there without reacting with the limiting reactants. You're going to follow the same steps. Remember that we're using mole ratios to find quantities. Now, the limiting reactant was the iron trioxide. So I have to use a mole ratio that is including that substance in there. But in addition, remember that I'm looking for the extra mass of sodium that didn't react. First, okay, I'm going to find the amount that was reacting with my limiting reactant. Okay, when I'm writing this proportion, and over here I have that the amount of sodium that react was equal to 3.78 moles. That was the amount of sodium that react with my limiting reactant. But that's not what I want, because I want to know the amount that was in excess, and you know that at the beginning of the problem, we have 100 grams of sodium. This answer is a mole, so I need to convert that into grams, to know what is the mass of sodium that reacts with my limiting reactant, which is the iron. And 86.90 grams of the sodium was able to react with a given amount of iron trioxide. Now, in my problem, 100 grams were given. They are looking for the difference. The mass in excess that didn't react, that just stays in there without completing the reaction. How are you going to find the difference? By subtracting. That's how you find that 13.1 grams of sodium didn't react because there was not enough iron trioxide. item 3 exile. With this problem, if you follow the steps in this problem, you're gonna be able to solve any limiting reactant problem. So you have this wonderful resource that you can use in addition to the visual presentation. If you don't understand that today, you understand that tomorrow, or you understand that when you go to college, and limiting reactant is one of the skills that you have to master.